Hello, boys and girls and Stingray parents. This evening we're going to be looking at inequalities. We will be comparing and contrasting them with equations. You'll be seeing some similarities and differences, as well as we're going to graph inequalities. And I think that'll help you get a better perspective on what inequalities are. Well, let's take a look at a few sample problems, shall we? Boys and girls, here we have three different problems. One is an equation, and the other two are inequalities. And what I hope for us to see is that when we solve both inequalities and equations, we solve them pretty similar. We have the same strategies to solving them, but we're going to see our answer is a little different, or I should say answers in some cases. Let's start off with our inequalities. Now, we've practiced these quite a bit. We know that the first step is always simplify. And when we look at this, we see that there's really no simplification to be done. In fact, all these problems right now, if you look at them closely, you can tell they're already in simplest form. There's no mathematical operations that you can perform outside of solving for the variable. So therefore, let's jump to the heart of the problem. We need to solve for these variables, or we need to isolate these variables, get them all by themselves. The first step when isolating the variables, you want to ask, is anything being added or subtracted on the variable side? You need to take care of that first. A lot of people, well, let's get rid of this 3 here. No. Let's get rid of this divide by 3. No, let's get rid of this. You can't do that. Okay, you need to first ask yourself, is there anything being added or subtracted on the variable side? And we can see that there is. 5 is being taken away on the variable side of the equation. So once again, for isolating the variable, we must do the inverse operation. What's the inverse operation of minus 5? It's plus 5. So we're going to write a funky addition problem here. We add 5. And what we do to one side of the equation, we must do to the other. So we also need to add 5 over here. Okay, take away 5, add 5, they cancel each other out. And then we bring down our 3y. That's all that's left on the left-hand side of this equation, 3y. And 10 plus 5 is 15. Okay. Did we isolate the variable? No, but we're getting closer. We're one step away. Now we can ask what's happening to the variable. It's being multiplied by 3. What's the inverse operation of being multiplied by 3? It's being divided by 3. So we divide this by 3. And what we do to one side of the equation, we must also do to the other. So we divide both sides by 3. And finally, we've isolated y. And 15 divided by 3 is 5. So y is equal to 5. And if we were to graph that, it's kind of a boring thing to graph. You know, here's our number line. We could put let's put 0 right here, and then over here we'll put 5, and actually that would be a negative 5, and over here would be a negative 10. Over here we would have 5, we're counting by increments of 5, and over here we'd have 10 approximately. And if y equals 5, we would just graph it like that. We put a big old solid dot around 5. That's it. Not too exciting. Let's take a look at the inequality though. Okay, once again, when we solve for a variable in an inequality, and this is y divided by 3 minus 5 is less than 10. Okay, that's an inequality. It's saying here's our balance. Okay, but rather than saying the left is equal to the right, it's saying that the left is less than. It has a lesser value than what's on the right. What's on the right is greater than what is on the left. Okay, so once again, we're going to solve it just like an equation. We need to ask, is anything being added or subtracted on the variable side? And the answer is yes. Okay, so if we want to begin to isolate y, the variable, we must do the inverse operation of minus 5, which is plus 5. So we're going to add 5 here. And what we do to one side of the equation, we must do to the other. So we're going to add 5 over here as well. Minus 5 plus 5, they're opposites. They cancel each other out. So we just bring down the y divided by 3. We bring down our comparison sign, our less than sign. And 10 plus 5 is 15. Okay, so now we have y divided by 3 is less than 15. We see that our problem is we're getting closer to having y all by itself, but we still have a little work left. The y is not all alone. It's not isolated. It's being divided by 3. So we ask ourselves, what's the inverse operation of divided by 3? It's multiplying by 3. So we need to multiply this side by 3. What we do to the left, we must do to the right. So we're going to also multiply the right-hand side by 3. And the 3's cancel each other out. I'm left with a y is less than 45, which is 15 times 3. Let's graph this. Now we're going to see, when we solved for this problem, it looked just like we were solving for an equation. But when we graph our answer, we're going to see something different happen. Let's put we're going to put 0 right here. Okay, and over here we'll say this is, let's say this is 15 or a negative 15. And over here would be negative 30. Okay, and this graph is going to be completely accurate. Over here we're going to have 15. Here we'll have 30. And over here we'll have positive 45. Now how would we show this? How would we show this? Well, we know that y is less than 45. Okay, so it's positive 45, which is right there. And then we would draw an arrow. Okay, so that means y can be anything less than 45. Can it be equal to 45? No, because if we were to substitute y with 45, 45 is not less than 45. But we could use 44, 40, 30, 15. We could use 0, and we could use any negative number to make this statement true. So when we graph an inequality that has a less than or greater sign, we put a circle around our key number that we know it has to be less than or greater than, but we can't fill it in. Okay, because if we fill it in, it means something a little different. We're going to find that out in a moment. Let's take a look at our last example. Here we have 4y plus 5 is less than or equal to 17. Once again, we're going to solve this equation, this inequality, the same way we would an equation. But now when we go to graph, we're going to see something even yet different again. Can we simplify? No, it's in simplest term. So we begin to isolate. Is there anything being added or subtracted on the variable side? Yes, a 5 is being added. What's the inverse operation of plus 5? It's minus 5. So we have to subtract 5 to begin isolating the variable. And what we do to the left-hand side, we must do to the right. So we subtract 5 from both sides. That cancels out the 5. I'm left with a 4y on the left-hand side. I bring down my comparison sign, less than or equal. 17 minus 5 is 12. Okay? We're not done isolating yet. There's still more work to be done because what's happening to the variable? It's being multiplied by 4. What's the inverse operation of times 4? How do we undo or reverse times 4? We divide it by 4. And what we do to one side, we must do to the other side. So the 4's cancel each other out. I'm left with y is less than or equal to 12 divided by 4, which is 3. Now let's graph this one. Here we have our number line. Okay, and I'll put 0 right about here. Over here I'll put a -1, -2, and so forth. Over here I'll have a 1, 2, and a 3. I could go on, but I don't have to. And this says that y is less than or equal to 3. Well, I'm going to circle 3, and I'm not going to stop there because it says that y can be equal to 3. If y can be equal to 3, I can fill it in solid. That says that y can be equal to 3 because 3, is that less than or equal to 3? Yeah, it's equal to 3, so it's true. It's a true statement. But it can also, y can be anything less than that. So I'm going to draw an arrow going off to the left, showing that it can also be any value less than 3, as well as 3. And there you have it.